A wetland is a land area that is saturated with water, either permanently or seasonally, such that it takes on the characteristics of a distinct ecosystem. The primary factor that distinguishes wetlands from other landforms or water bodies is the characteristic vegetation of aquatic plants, adapted to the unique hydric soil. Wetlands play a number of roles in the environment, principally water purification, flood control, carbon sink, and shoreline stability. Wetlands are also considered the most biologically diverse of all ecosystems, serving as home to a wide range of plant and animal life. Wetlands occur naturally on every continent except Antarctica, the largest including the Amazon River Basin, the West Siberian Plain, and the Pantanal in South America. The water found in wetlands can be freshwater, brackish, or saltwater. The main wetland types include swamps, marshes, bogs, and fens, and subtypes include mangrove, carr, pocosine, and vasy. The UN Millennium Ecosystem Assessment determined that environmental degradation is more prominent within wetland systems than any other ecosystem on Earth. International conservation efforts are being used in conjunction with the development of rapid assessment tools to inform people about wetland issues. Constructed wetlands can be used to treat municipal and industrial wastewater as well as stormwater runoff. They may also play a role in water-sensitive urban design. Definitions: a patch of land that develops pools of water after a rainstorm would not be considered a wetland, even though the land is wet. Wetlands have unique characteristics. They are generally distinguished from other water bodies or landforms based on their water level and on the types of plants that live within them. Specifically, wetlands are characterized as having a water table that stands at or near the land surface for a long enough period each year to support aquatic plants. A more concise definition is a community composed of hydric soil and hydrophytes. Wetlands have also been described as ecotones, providing a transition between dry land and water bodies. Mitch and Gosselink write that wetlands exist at the interface between truly terrestrial ecosystems and aquatic systems, making them inherently different from each other, yet highly dependent on both, in environmental decision-making. There are subsets of definitions that are agreed upon to make regulatory and policy decisions. Technical definitions: a wetland is an ecosystem that arises when inundation by water produces soils dominated by anaerobic processes, which, in turn, forces the biota, particularly rooted plants, to adapt to flooding. There are four main kinds of wetlands: marsh, swamp, bog, and fen. Some experts also recognize wet meadows and aquatic ecosystems as additional wetland types. The largest wetlands in the world include the swamp forests of the Amazon and the peatlands of Siberia. Ramsar Convention definition: under the Ramsar International Wetland Conservation Treaty, wetlands are defined as follows. Article 1.1. Wetlands are areas of marsh, fen, peatland or water, whether natural or artificial, permanent or temporary, with water that is static or flowing, fresh, brackish or salt, including areas of marine water the depth of which at low tide does not exceed 6 meters. Article 2.1. Wetlands may incorporate riparian and coastal zones adjacent to the wetlands, and islands or bodies of marine water deeper than 6 meters at low tide lying within the wetlands. Regional definitions: although the general definition given above applies around the world, each county and region tends to have its own definition for legal purposes. In the United States, wetlands are defined as those areas that are inundated or saturated by surface or groundwater at a frequency and duration sufficient to support, and that under normal circumstances do support, a prevalence of vegetation, typically adapted for life in saturated soil conditions. Wetlands generally include swamps, marshes, bogs and similar areas. This definition has been used in the enforcement of the Clean Water Act. Some U.S. states, such as Massachusetts and New York, have separate definitions that may differ from the federal government's. In the United States Code, the term wetland is defined as land that has a predominance of hydric soils, is inundated or saturated by surface or groundwater at a frequency and duration sufficient to support a prevalence of hydrophytic vegetation, typically adapted for life in saturated soil conditions and under normal circumstances supports a prevalence of such vegetation. Related to this, legal definitions. The term normal circumstances are conditions expected to occur during the wet portion of the growing season under normal climatic conditions, and in the absence of significant disturbance. It is not uncommon for a wetland to be dry for long portions of the growing season. Wetlands can be dry during the dry season and abnormally dry periods during the wet season. But under normal environmental conditions, the soils in a wetland will be saturated to the surface or inundated such that the soils become anaerobic, and those conditions will persist through the wet portion of the growing season. Ecology. The most important factor producing wetlands is flooding. The duration of flooding determines whether the resulting wetland has aquatic, marsh or swamp vegetation. Other important factors include fertility, natural disturbance, competition, herbivory, burial and salinity. When peat accumulates, bogs and fens arise. Characteristics. Wetlands vary widely due to local and regional differences in topography, hydrology, vegetation, and other factors, including human involvement. Wetlands can be divided into two main classes: tidal and non-tidal areas. Hydrology. Wetland hydrology is associated with the spatial and temporal dispersion, flow, and physiochemical attributes of surface and groundwater in its reservoirs. Based on hydrology, wetlands can be categorized as riverine, lacustrine, and palastrine. Sources of hydrological flows into wetlands are predominantly precipitation, surface water, and groundwater. Water flows out of wetlands by evapotranspiration, surface runoff, and subsurface water outflow. Hydrodynamics affects hydroperiods by controlling the water balance and water storage within a wetland. Landscape characteristics control wetland hydrology and hydrochemistry. The O2 and CO2 concentrations of water depend on temperature and atmospheric pressure. Hydrochemistry within wetlands is determined by the pH, salinity, nutrients, conductivity, soil composition, hardness, and the sources of water. Water chemistry of wetlands varies across landscapes and climatic regions. Wetlands are generally minerotrophic with the exception of bogs. Bogs receive their water from the atmosphere and therefore their water has low mineral ionic composition because groundwater has a higher concentration of dissolved nutrients and minerals in comparison to precipitation. The water chemistry of fens ranges from low pH and low minerals to alkaline with high accumulation of calcium and magnesium because they acquire their water from precipitation as well as groundwater. Role of salinity. Salinity has a strong influence on wetland water chemistry, particularly in wetlands along the coast. In non-riverine wetlands, natural salinity is regulated by interactions between ground and surface water, which may be influenced by human activity. Soil carbon is the major nutrient cycled within wetlands. Most nutrients, such as sulfur, phosphorus, carbon, and nitrogen are found within the soil of wetlands. Anaerobic and aerobic respiration in the soil influences the nutrient cycling of carbon, hydrogen, oxygen, and nitrogen, and the solubility of phosphorus, thus contributing to the chemical variations in its water. Wetlands with low pH and saline conductivity may reflect the presence of acid sulfates, and wetlands with average salinity levels can be heavily influenced by calcium or magnesium. Biogeochemical processes in wetlands are determined by soils with low redox potential. Wetland soils are identified by redoxymorphic mottles or low chroma, as determined by the Munsell color system. Biota. The biota of a wetland system includes its vegetation zones and structure as well as animal populations. The most important factor affecting the biota is the duration of flooding. Other important factors include fertility and salinity. In fens, species are highly dependent on water chemistry. The chemistry of water flowing into wetlands depends on the source of water and the geological material in which it flows through, as well as the nutrients discharged from organic matter in the soils and plants at higher elevations in slope wetlands. Biota may vary within a wetland due to season or recent flood regimes. Flora. There are four main groups of hydrophytes that found in wetland systems throughout the world. Submerged wetland vegetation can grow in saline and fresh water conditions. Some species have underwater flowers, while others have long stems to allow the flowers to reach the surface. Submerged species provide a food source for native fauna, habitat for invertebrates, and also possess filtration capabilities. Examples include seagrasses and eelgrass. Floating water plants or floating vegetation is usually small, like Aroerum. Forested wetlands are generally known as swamps. The upper level of these swamps is determined by high water levels, which are negatively affected by dams. Some swamps can be dominated by a single species, such as silver maple swamps around the Great Lakes. Others, like those of the Amazon basin, have large numbers of different tree species. Examples include cypress and mangrove. Fauna. Fish are more dependent on wetlands ecosystems than any other type of habitat. 75% of the United States' commercial fish and shellfish stocks depend solely on estuaries to survive. Tropical fish species need mangroves for critical hatchery and nursery grounds and the coral reef system for food. Amphibians such as frogs need both terrestrial and aquatic habitats in which to reproduce and feed. Wild tadpoles control algal populations. Adult frogs forage on insects. Frogs are used as an indicator of ecosystem health due to their thin skin, which absorbs both nutrient and toxins from the surrounding environment, resulting in an above-average extinction rate in unfavorable and polluted environmental conditions. Reptiles such as alligators and crocodiles are common reptilian species. Alligators are found in fresh water along with the freshwater species of the crocodile. The saltwater crocodile is found in estuaries and mangroves and can be seen in the coastline bordering the Great Barrier Reef in Australia. The Florida Everglades is the only place in the world where both crocodiles and alligators coexist. Snakes, lizards and turtles also can be seen throughout wetlands. Snapping turtles are one of the many kinds of turtles found in wetlands. Mammals include numerous species of small mammals in addition to large herbivorous and apex species such as the beaver, swamp rabbit, and Florida panther, live within and around wetlands. The wetland ecosystem attracts mammals due to its prominent seed and vegetation sources, abundant populations of invertebrates, small reptiles and amphibians. Monotremes such as the platypus is found in eastern Australia, living in freshwater rivers or lakes. Much like the beaver, the platypus creates dams and burrows for shelter and protection. The platypus swims through the use of webbed feet. The platypus feeds on insect larvae, worms, or other freshwater insects, hunting mainly by night by the use of their bill. It turns up mud on the bottom of the lake or river, and with the help of the electroreceptors located on the bill, unearths freshwater insects. The platypus stores their findings in special pouches behind their bill and consumes its prey upon returning to the surface. Insects and invertebrates total more than half of the 100,000 known animal species in wetlands. Insects and invertebrates can be submerged in the water or soil, on the surface, and in the atmosphere. Algae are diverse water plants that can vary in size, color, and shape. Algae occur naturally in habitats such as inland lakes, intertidal zones, and damp soil, and provide a dedicated food source for animals, fish, and invertebrates. There are three main groups of algae. Plankton are algae which are microscopic, free-floating algae. This algae is so tiny that on average, if 50 of these microscopic algae were lined up end to end, it would only measure 1 millimeter. Plankton are the basis of the food web and are responsible for primary production in the ocean using photosynthesis to make food. Filamentous algae are long strands of algae cells that form floating mats. Chara and Nitella algae are upright algae that look like a submerged plant with roots. Climates. Temperatures vary greatly depending on the location of the wetland. Many of the world's wetlands are in temperate zones. In these zones, summers are warm and winters are cold, but temperatures are not extreme. However, wetlands found in the tropic zone, around the equator, are warm year-round. Wetlands on the Arabian Peninsula, for example, can reach 50 degrees Celsius and would therefore be subject to rapid evaporation. In northeastern Siberia, which has a polar climate, wetland temperatures can be as low as -50 degrees Celsius. In a moderate zone, such as the Gulf of Mexico, a typical temperature might be 11 degrees Celsius. Wetlands are also located in every climatic zone. Rainfall. The amount of rainfall a wetland receives varies widely according to its area. Wetlands in Wales, Scotland, and Western Ireland typically receive about 1,500 mm per year. In some places in Southeast Asia, where heavy rains occur, they can receive up to 10,000 mm. In the northern areas of North America, wetlands exist where as little as 180 mm of rainfall each year. Temporal variation. Perennial systems. Seasonal systems. Episodic system of the down. Surface flow may occur in some segments, with subsurface flow in other segments. Ephemeral systems. Migratory species. Human disturbance. Encroachment, drainage, development, overgrazing, mining, unsustainable water use. Ecosystem stress, water scarcity, endangered species, disruption of breeding grounds, imbalance in sediment load and nutrient filtration.